Again, here's 2013, question 10. It's in the geometry section. We've got a ship with a viewing platform 23 metres above the sea level in a calm sea. Calculate the distance to the horizon. So this is a very standard type of question, distance to the horizon, so we draw this sort of picture. That is a very, very out of scale picture of the Earth, and this is my 23 metres. As you can see, it's completely not to scale, but I do it so that you can see very clearly what's going on here. That's my little viewing platform for my ship, and I will keep that line going until it reaches the centre of the Earth. From the top of that viewing platform you can see the horizon. If I draw a line to there, the horizon will be there. That's a perfectly straight line, as you can see. Then I will make another line from my centre of my Earth up to that point at which that line just touches the Earth. That line is a tangent to the Earth. That is the one from the viewing platform looking this way across and just seeing just the horizon. The whole thing about tangents to the Earth is that when you draw a line from the centre of the Earth to the edge, and that tangent always form a right angle up in the corner there. And so when there's a right angle, we can use Pythagoras' theorem, which is how we solve this type of question. Now, we know that the height above the Earth is 23 metres. We know that the length of the radius of the Earth is 6371, but that's in kilometres. So first to do this, we have to change the 23 metres we've got into kilometres. So 23 metres equals how many kilometres? Well, to change from metres to kilometres you have to divide by 1000, because there's 1000 metres in a kilometre. And that means you move the decimal point 3 places here. You go 1, 2, 3. We'd end up with 0.023 kilometres. So the length in my right angle triangle that I drew of that long side, the hypotenuse, is the 6371 for the radius of the Earth, plus that little bit that we're sticking up, which is the 0.023, which gives us 6371.023 kilometres for the length of the hypotenuse, and the distance to the horizon, that little bit there, we'll give it a d. That's the bit we're trying to find. Now, what Pythagoras' theorem says about any right angled triangle is that a squared plus b squared equals c squared, where a and b are the short sides and c is the long side or the hypotenuse. In my picture here, the long side is this 6371.023, and the two short sides are d and the 6371. So in my equation here, a is a short side, b is a short side, and c is the long side. My little a will be 6371, plus my little b is my distance, so it's my distance squared, and c is that 6371.023 squared. And from that we solve this equation to find what d is. Well, we will just use the calculator to do that, because the calculator is terribly good at calculating. So, keyboard. Here we go. Normally I get keyboard, calc, solve. That's where I find my solve button, and we just put it all in, and the calculator pops out the answer. So here we go, 6371 squared. 6371 squared plus, now in this equation here we've got a d. The calculator is more used to, it can work with d's if I want to make it to, but it's probably easier just to put an x in instead of that. So plus that x squared, and that all equals that big number squared, 6371.023 squared. And close off the solve function and exit, and it pops out the answer. It gives me two solutions. It gives me the negative and the positive solution, because when you solve this, take the square root of a number, you do get a positive and negative solutions. In this case, we are only interested in the positive one, because it doesn't make sense to have a negative length. So in this case, we have got 17 point, and I'll go to 2 places of decimals. We've got 17.119. To go to 2 places of decimals, you look to the third place, which is a 9, and so we will round up, and it'll be 17.12. 17.12, and we are dealing in kilometres now because we changed everything to kilometres. And that is the first part done.